What's up? Welcome back to our galaxy and beyond. Excuse me.
Peace, everybody.
With
Peace.
Anthony and Juju.
What's happening, Miss Juju? You doing all right?
I made it finally.
Hey.
Hair a little on the wild side, but I know y'all was tired. I was tired of that little Afro puff. Yeah. Yeah, I finally made it though. I had some complications. Sorry y'all for the late start. But it is what it is.
It's all good. It's all good. We're going to get this information out there, turn them on to some African American scientists, and call it a night.
I think that's going to be the best part though.
Yeah, I think so too.
And I think y'all be pleasantly surprised on who we're actually going to be honoring for the ending of Black History Month. So thank you. Appreciate everybody for coming out. You want to give a few shout outs before we get started?
Oh, yeah. First and foremost, I know he's not in here, but I want to send a shout out to the God Killer, Bobby Banger. Appreciate you, my brother, for all your help. The Pseudo Killers, of course. Great team, one of the best teams I've ever been assembled with. And those in the chat, Miss Valicia Bennett, appreciate you for showing up all the time. Omar Reed, appreciate you, my brother. Appreciate you. But other than that, just like to get it on record. When you're scientifically literate, they can't drag you down to their level and beat you up with experience. So let's get it in.
Let's go. Yeah, so I feel like I wanted to start with star types. So just a quick recap. I think the last show that got pew pew, but those who saw, we dealt with like star evolution, right? We dealt with how stars are forged and the processes they go to. And just to reiterate quickly, you have these molecular clouds or planet or nebulas, which are what we call them stellar nurseries or whatnot, and they're formed after these gases. And I'm gonna give y'all the children's book version, but Anthony will give y'all the adult version in the middle, at where I left off. But once these gases gets so dense and so much gravity, they begin to, because of the gravity, they begin to collapse on themselves, and then you start to have these star formations. And the order to do that, there's got to be some fusion got to start happening, right? And that fusion is a interesting process. Me and Anthony just spoke about this. It may not be all stars, it may be some stars, but the process pretty much goes like, it's going to start fusing hydrogen. And then when all the hydrogen is done fused out, and a nuclear fusion is what, is protons, right? And they swirling around. And you need fusion. And in order to create fusion, it has to be really fast and really hot. So while you got these fast spinning protons bumping off of each other, you need them to, collide, right? In order to do that is with the heat. So if you got that fast moving, that fast spinning, and that heat, then they'll collide, and that's called fusion. So when those collide, you got hydrogen. After that, you got some helium. Not for all of them, but for the basic process, that's how it goes. After that, it'll be some carbon. After the carbon fused off, now it's fusing. What is that? Oxygen. Then you got a little bit of neon. Then you got some silicone, and then it gets to the iron. And once it gets to the iron, it's like dead. Either gonna be a black hole or it's gonna do some like supernova stuff, right, Anthony? But that ain't for all stars. He just said that's for the big ones. I can't hear you, Anthony. But I am gonna show y'all pretty.
I'm sorry. I was on mute. I'm sorry.
Ooh, don't do that. I was like, that's why I said, boy, let me say something.
No, but what what you're speaking of, yeah, that's pretty much the cycle of the life cycle of a star. You know, you start with the nebula, or molecular cloud. Is it's you'll hear it phrased both ways, but within that molecular cloud, it starts to clump, and those clumps, the bigger the clumps get, the is going to determine the strength of the gravity. So as they start to clump, it gets bigger and bigger, and the gravity causes it, to coalesce. And as you get enough gravity and enough mass, as the star builds up enough mass, it starts to fuse those atoms. And in fusing those, there's, like you said, the heat and the pressure. It,
Pressure.
yeah, that heat and that pressure is going to counteract the gravity trying to collapse the star.
Hmm.
And that's when the star moves into the main sequence phase. It's actually fusing hydrogen. And all stars do this, no matter what, you know, all except the smallest stars, which are the red dwarfs and the brown dwarfs. But all the rest of them on that Hertzsprung-Russell, from O through M, or in reverse, M through O,
Yeah.
those stars are fusing hydrogen.
So
Now,
how do you remember it? I remember it by MKG Fab. Fabo, because it's MKGFAB. Oh, and the reason why I remember that, because it's Machine Gun Kelly, even though the K and the G is backwards, but I'm dyslexic, so it works for me. And Fabo, fabulous. I don't know. That's just how I remember it. But the M is the coldest, the coolest stars,
yeah,
and as you move along, they get hotter and hotter until you get to O. But that's how I do it. I know Anthony gave how he remembers it. So if you want to tell him how you remember Anthony, let him know. Tell the people how you know.
yeah, it's well, I learned it, just by, you know, watching certain shows, like I mentioned, How the Universe Works. That's a really good series, but
Mm-hmm.
that's where I heard it first. And it's okay, the letters are OBAFGKM. So it would be OBA, fine girl, and kiss me. So, but you put it a pretty good way. I'd never heard it that way. I'd never even thought to do it backwards. But whatever works, you know what I'm saying? Whatever works. So, but that's the way I learned it. And yeah, those stars, like I said, OB, those classifications
Mm-hmm.
are determined by the color, the temperature, and the mass of the
Right.
star. And it's the mass that's gonna make it more, the higher the mass, the higher the temperature of the star, which would make it be blue. The
Mm-hmm.
most massive and the hottest stars are the blue ones. So you can correlate that, like I mentioned in the last show, to, like, if you ever seen like a flame coming from a gas stove or a propane stove. If you look towards the bottom of the flame, it's blue, and then it goes to red towards the top of the flame. And if you take a thermometer and you stick it in the blue part of that flame, you'll see that it's hotter than the red part of the flame. So that's another way that you can kind of correlate the color and the temperature to something in reality. You know what I'm saying? So, and there's a law, it's called Wien's Law, Weins, that, you know, that kind of, well, not kind of, but it goes through that process of determining color and, you know, and temperature, you know, so that's something we can look into. But like I said, Weins, Wien's Law. Okay, this diagram is Juju got up now. This one shows the size correlation in color for for stars in the main sequence. So the most massive, which would be the biggest, would be O, and as you can see, and it goes down, or you can start at M and go up. Either way, it doesn't matter.
Yeah, I started at M and went up, but you know, I'm
Yeah,
dyslexic, so it works.
either way, whichever works. So I hope that answered your question there, Joel. Yeah, you can determine the temperature from the color.
Right.
And like I said, there is a chart that
Oh, I got
correlates all this
it.
information.
I'm gonna show that the Hertzsprung
The Hertzsprung-Russell diagram.
Russell diagram, which they say is like the periodic table to chemists, is what that is to astrophysics. Which I
Yeah,
was like, that's the most important thing to have. Is
yeah,
that periodic table when you come to chemistry. So imagine for astrophysics, like that's definitely you have to have that like on you every day, like one of your little cheat cards, I guess to say. But and another thing I wanted to mention, which was easy also to remember how stars are forged, is that the bigger the star, the shorter the life, and the more violent death. Um, the smaller the star, the longer the life, and they usually have like a slow, quiet death. But yeah, I thought that was interesting. And
and
I'm
you
gonna
know that's counterintuitive, Miss Juju,
right.
because
You think the
you
bigger
you
lives
would
longer?
think, yeah, you would think that a star that contains way more hydrogen would be able to last longer. You know
Mm-hmm.
what I'm saying? But the fact that it contains much more hydrogen
Mm-hmm.
makes it the nuclear fusion happen faster.
Correct.
So,
It's
you know,
crazy, right?
that's
Very
counterintuitive.
counterintuitive. Shout out Brazilian Monk joining us. That's what's up.
And I
Um,
got one question I want to get before we go too far.
I'm
It's
not gonna go
pertaining to
too
this.
far, but I want to let
Okay,
people
go
know what
ahead.
this picture was so I can change the photo. Like I gave it to y'all, then I took it off. So right before you get to question, we talked about proto stars. That's the beginning phase when they're birthright, and then goes into Titari star. Did I say that right? But
Yeah.
either way, because y'all know I'll be working on my words. This is a picture of a Tatari star. This is actually from the Hubble spacecraft, and I have a pretty awesome surprise for you all concerning that. But go ahead. I just wanted to let y'all know what that was. That image is a Tatari star. So that's right after the protostar and before it gets to the main sequence.
Mm-hmm.
So it's still working out things. I think how they say like
Mm-hmm.
it kind of flickers in and out. So it's like working on stabilizing its gravity force or something like
Yeah.
that. Mhm.
Mm-hmm.
Yeah. Okay. So go ahead.
Yeah, and the question we have is, with the weight of the stars, are you able to calculate the speed of gravity around it?
Mm.
That's one that I'm gonna have to look into a little bit more as far as calculating the speed of gravity.
Mm.
But I do know that using stars, you can determine the the gravitational effects of, you know, said star. Prime example would be, okay, like back in 1919, a dude named Arthur Eddington went out to West Africa, and they measured they observing the eclipse, and they could
Mhm.
see stars that they know were directly behind the sun, which we can't see in the daytime. But during that eclipse, they could actually see those stars because of the gravitational effects that our sun has. It warped space. So I don't know if you can measure a speed. Like I said, I have to look into that a little bit more. Sorry, I can't get as accurate for you at the moment, but I'll have a good answer for you there in the comments after the show. Give me a couple of days to look into that.
Yeah, boy.
Mr. Webbs.
We love the interaction. That's for sure.
Most definitely.
Keep the questions coming. Shout out Zane. What's up, fam? And Mongo Slade. Omar. I just had to shout you out. Yeah. And Felicia. Number
Oh
one.
yeah.
What's up, Immortal Truth? Yeah. So we like the interaction. So please keep the questions coming. So since we kind of gave you the overview and added a little bit of things from the last show as far as stellar evolution, how stars are forged, so to speak, we wanted to get into the types of stars and how to categorize. So we already spoke on one of them actually, and so what we spoke on when we're talking about the MKG FABO is called stellar classes, and then you have what's called what is it? Stellar types, and those are usually with numbers. And I believe how it works is the lower the number, the hotter the star. Okay, and it goes from 0 to 9. So, for instance, we already talked about stellar classes with the letters, and we showed you the diagram, right? And so G sits kind of in the middle, but more on the smaller side of the middle of the classification of stars. But when it comes to its stellar type, it's actually one of the hotter on the hotter side of the stars in its type, if y'all understand that. Did I say that right, Anthony? Did I get that right? So what we're looking at right now is our sun. You are my light. Yeah. So this is our sun.
And that's the light of the world.
That's the light of the world. For sure. This is a pretty awesome picture right here. This is a lot of the ways that we take pictures of sun, or scientists talking about scientists take pictures using different colors. This may not necessarily be the natural color, but of course, and I think we need to do a show on that, how they take pictures and why and how they color them, because they actually are helpful in providing different types of information depending on what type of astronomical tool, scientific tool they use to take the photo and different things like that. But this is our sun. And so what I'm understanding is that usually when we're talking about stellar classes, that's only during the main sequence of the stars, which is the longest time that a star, that's the category which the star stays in for the longest time. So all stars are going to stay in the main sequence longer than any other part of their stellar life. Stellar life, stellar, like cellular. Man, talking about a little dyslexic ADD behind. But this is the sun. This is in its main sequence, and it's a G. That's a stellar class. And it's on the scale 0 through 9. It's a 2. So remember, 0 is the hottest, 9 is the coolest. So
and that's within that classification.
Within that classification. So each classification has the class, but then it has a measurement of the types within the classification, not amongst all the classes, but just the classification. Because compared to the other classes, this is actually a really kind of on the cool side of stars, I think. But this beautiful. So yeah, man, I gave y'all sources, and I even had a little section that said additional resources. If y'all don't check them out in that description box, you are losing out. I gave y'all some jewels today. Thank me later. Thank you later. But no, this is pretty awesome, and I want to play with it so y'all can see. Pause. But no, really, what's going on here? So this is from NASA, and this is the star types. How easy is that, right? and it's going to go through the main sequence, and it tells you a little about the main sequence. And this is going in chronological order of the classifications. Then it gets into the red giant, and this is after I'll give you the kindergarten version. You know, loses like one shell, and then it's fusing some other things. I believe this starts fusing helium here or whatnot. And then it has like, you know, this interesting color. It's called red, but usually they're more like orangey type or whatnot. And you want to get into that a little bit, or do you want to say something about main sequence before we move?
Okay, I'm gonna address this one question here,
Oh
which
yeah,
is about main sequence.
Go ahead, go off.
To Immortal Truth, question
What up,
is,
Immortal?
do we know, and peace to you, appreciate you coming in and your interaction now.
Absolutely.
Questions, do we know what the star are made of? All stars on the main sequence are fusing hydrogen to helium. So if you look at that periodic chart, it'll you'll be able to see it. We don't do we have that? We don't have that periodic chart, do we, Miss Juju?
Let me see if I can find it. Let me see the one that you did.
Yeah, you want me to send it to you real quick?
If you got it right on here, heck yeah, email it to me.
I can.
I got jokes.
Yeah, but what it is okay, from the Big Bang.
Email it to me real quick. Do you have it or no?
Yeah, I'm pulling it up now.
Okay.
But from the Big Bang, we were left with mostly hydrogen, a little bit of helium, and a small trace amount of lithium. The hydrogen is the most dominant element in the universe, if you want to say it that way. We have more hydrogen than anything. So stars on the main are classified as on the main sequence because they are fusing the hydrogen. Once they start fusing other elements, then it has moved off of the main sequence. So the majority of the stars that you see in the night sky, those stars, no matter what color it is fusing hydrogen. Like I said, the amount or the mass of the star is going to determine how fast and how hot it gets, but it's still going to be burning hydrogen. So, yeah, give me 1 second. But yeah, when you look at that periodic chart, it's the way it's laid out. You'll see that hydrogen is the most abundant, followed by helium, and other. I'm getting it to you right now, Miss Juju. It should be coming through.
All right, and I'll get that for you all right now.
Yeah. But yeah, they're fusing hydrogen, and once they run out of hydrogen, then they'll swell up and begin to fuse helium. And that's when it swells up, it goes into helium flash. That's what they call it. So it'll swell up, get red, then it'll come back down, get to blue. Okay, so if you look at this periodic chart here, you see at the top left, that blue, that hydrogen. And if you look at the key at the top, it'll tell you how those elements are created, what kind of action it takes to create those elements. Anything with blue was created during the Big Bang. Anything with green is a dying low mass star, which would be a star like the sun or anything smaller, low mass stars. And so forth and so on. You see the colors, yellow is, that's how all those elements that are in yellow, that's what it would take to fuse them. Now with stellar fusion, it's going to stop at iron, Fe. That's where it's going to stop. So all those elements up to Fe are fused together in stars based off the mass of the star. Our sun, it's gonna fizzle out around
5 billion.
yeah, we got about 5 billion more years left for our sun.
And
But
it
it's
goes,
gonna keep fusing, it's gonna be fusing hydrogen that whole time. And once
mhm,
it run out of hydrogen, it starts to fuse helium.
that's the red
Then it's
giant.
gonna,
Then it's gonna
things
be,
are gonna change for it, and it's gonna turn into a red giant and become a white dwarf.
mhm.
So,
Now, the white dwarf activity is probably gonna be another 10 billion years. Is it?
well,
Is
the thing about white dwarfs is we have not had the universe isn't old enough for a white dwarf to burn out. So we don't know what happens to a white dwarf after it, actually cools off. Now they
I'm
have
saying
some
how long?
hypotheses. We don't know.
Now I'm saying how long, like they say, to get to red giant status, just in 5 billion, and then
Oh
that'll
yeah, for the
be like
sun.
another 5
Well,
billion. Yeah. Then
for
it'll be a white.
that process will start in about 5 billion years,
Hmm.
because they say we got about 5 billion years worth of hydrogen left in the sun. So yeah.
Thank you, Mr. Webbs. We appreciate that. And I just want to say shout out to Mac Rob, Pseudo Killer Official in the building. Thank you, sir. He is Mr. Black History himself. We might have to do a show on that one day.
Oh yeah.
Yeah,
And
so I'll get back to the star type real quick. But yeah, this periodic table is dope. Like, if I had a periodic table like this in high school, like I didn't do too bad in chemistry. I ain't gonna lie, but it probably would have been a little bit more easier and entertaining to actually understand it like that. Like, I don't even remember the teacher saying, "Yeah, you know, the elements all come from the stars." Like, how I don't remember that. You know what I'm
yeah,
saying? I think that's the first way. Well, my idea of how pedagogy should go as far as chemistry is, you should start with the stars because that's something that's visual, right? And
yeah,
I think most children are fascinated with the stars. So if you're dealing with a subject that's kind of complex, and chemistry is, I think you would deal with something that will actually interest just the general interest of young adults, right? And start with the stars. But I remember my teacher doing that, and he was a young dude too. Like, come
yeah.
on. You feel me? I mean,
Yes, indeed.
if anybody remembers that their teacher told them that elements came from the stars like that, please put a one in the chat. If you like me and you remember it, put a two, because I need to see if it's just me or was I not listening enough, because I don't remember that, because I would have been into it. I was already into the stars, but
Well, see this periodic table, and
oh,
peace to you, Mac Rob, Pseudo Killer Official. But you're absolutely right. Periodic table are dope, because that periodic table, it goes across different aspects of science. You know what
mm-hmm,
I'm saying? They use it in other fields, and it never changes.
mm-hmm,
You know what I'm saying? There are
right.
some things that have to be filled in. Matter of fact, you did on your Black History presentation last week. I think it was last week, or maybe week before last,
Clarice
about the young
Phelps.
lady. Yeah,
Clarice Phelps.
yeah, who actually discovered one of those elements that that are on
Yes,
this
sir.
table. You know what I'm saying? So, and yes, Zane,
That's what I
stars
said. Yes,
are
sir.
element warehouses. That's why all the chemical elements are forged in
Yeah,
stars.
yeah, they
Yeah,
they like the dope man in space.
that's where they're all forged at.
I'm
You know what I'm
sorry. Let
saying?
me let me stop. They got everything you need. Just go to the star.
Let's go to the stars. I mean,
Let's go to the
when
stars.
when the
Silent
pseudo
K. Silent
when the
K, you're not
pseudo
black.
says
We see you, Silent K.
when the pseudo said we are stardust, I mean literally we are. They taking it in a in a different
Yeah.
direction, but
And we said that they're messing it up a little bit, but go
yeah,
ahead, Anthony.
but that's what we are. And it's been said and stated that I have to find it. I can't remember. It's been a while, but it there was they can find chemical traces of over 60 different supernova that went off and formed the nebula that created our solar system. And a couple of those elements are, I think it's aluminum 26. They find all over Earth in asteroid rocks, which can only be forged in a supernova. And another one is iron, I think it's iron 60. And that's an
Oh
isotope of
no,
iron and an
that's
isotope
another class.
of huh?
I said, I don't know. Please don't ask me. That's all.
But yeah,
I ain't get that far.
Let me look that up real quick. But I think it's aluminum 26 and iron 60. So that's proof that, you know, there were other stars that went supernova. And to get into that question there on the screen, once, you know, like we were saying, main sequence stars, they're Mr. Webb's main sequence stars burn hydrogen to helium. A star like our sun is not going to go much farther than that. But a much more massive star like the O-type stars, they go on to forge other elements all the way up to iron. And once it reaches, and each phase leaves a shell around the core, like an onion, like Miss Juju was saying. So
we said that in private.
Yeah. Oh, okay.
Did we?
Yeah.
Oh yeah, maybe I did mention it a little bit. Okay, go ahead.
You have shells building up around this core in the sun. So you have a shell of hydrogen, a shell of helium, all the way up to iron. And it gets smaller and smaller. So, you know, it starts off with hydrogen, and then as it goes to helium, it gets smaller, and carbon and oxygen and neon, you know, down to silicon. And once it gets in each phase, the fusion happens quicker. It gets faster and faster. So you go from about a million years now for an O-type star, you go from like 1 million years to burning, or maybe 10 million years to burning hydrogen, down to 1 day to burning silicon. And then once it hits iron, it's over with. That's when your supernova happens. Now, everything that was built up in that shell, each layer around that core gets blasted off. And if you're either going to have a neutron star or you're going to have a black hole, one of the two. And that is determined by the mass, the initial mass of the star. So, yeah, I hope that answered your question.
I got another question for you, and I'm gonna show some pretty pictures, and then we'll get back to the star types, though. But
yeah, that'll work. And yes, to that question there, Immortal Truth, stars create life as we know it today.
Yes,
and
indeed.
The reason why we say that is because life as we know it today is carbon-based. So the only way we know of carbon being produced in the natural world is through fusion, stellar fusion. So to answer that question is yes, it's because it's carbon-based. Well, really, all the elements that we know of are, you know, being created some kind of way in stellar, you know, in a stellar evolution. So I hope that answers your question. I hope that's a good enough answer there. But yeah, stars create life. All the phosphorus, the potassium, the iron in our blood, the carbon base of our, you know, life itself, all of that is created in stars. And it takes supernovas to blast those elements out into the universe. And then you have other supernovas going off. And some can be close enough where a lot of this stuff, you know, it mixes together. So that's how that periodic chart is formed. So yeah.
And I want to add on to that. Not only is the periodic chart formed like that, so understand, and we spoke about this the last show because this is so exciting to me when I realized what was happening. But do you understand, like, the death of the star is the birth of the star? Because when those supernovas happen, and you have these clouds of more molecular clouds or dust clouds and all this material and different things in these gases, then you have the ability to have these what they call planetary nebulas. And
Yeah.
and then those can be like the Orion Nebula, which was like one of the first topics we covered. They're called literally stellar nurseries. Do you understand that? Stellar nurseries. So it's this the Orion Nebula is huge, right? And
Yeah.
you can see in some of the more cloudier parts of it where it has like these gas cloud blooms, the remnants
Mhm.
and these little protostars, or they call them globules or whatever, like the
Yeah.
little baby stars, like in a little sack
Mhm.
or something like that. Like it's fascinating. So it's literally like I don't like I don't know. It's just fascinating. So you have this process of it being in the
Mhm.
globule thing and it has the little accretion of the planetary disk. It's almost like a baby in the sack, and you got the umbilical cord. You feel me? But you got this
Yeah.
planetary disk in it, and it kind of grows with it, and then the little globule, the shell part falls off.
Mhm.
And then you got the protostar, and then after the protostar, then it's the little Titari star, and that's like the protostar is like the baby, right? It's like
Yeah.
the womb, and the Titari star is like a little toddler, because he
Mhm.
always trying to learn to walk and he wobbly, and so with the Titari star, it like kind of go in and out with this like what would I call it? The luminosity, I guess, or is that considered magnitude?
Well,
Um,
no, that's just a
that's the
phase that
main sequence only, though.
yeah,
But
yeah, it'll be hard to, get the magnitude or the luminosity of a
uh,
T-Tauri star
okay. But I'm just
in
saying,
that
like, it
phase.
has to figure out and stabilize its gravity.
Hmm.
So it
Yeah.
be doing some things, so it's a little wobbly, right? That's the little toddler and stuff. And then you got the main sequence. You feel me? That's
Yeah.
like he growing up now. You feel me? He almost grown. So yeah, I think that's fascinating. But the point is, when the star dies and it does all that, it leaves its remnants um is what it takes to create a star. So
Yeah.
just think about
And
that. It's a 360, y'all.
and all the planets and everything within that solar system will be made out of that nebula. And we
Mhm.
know that because all the rocks that fall to Earth, generally have the same chemical makeup.
Yeah, let me see if I can find one for y'all. I already showed you
And
a picture of the Tatari star. So is this part of Orion?
no, that's the Eagle Nebula there. That would be what they call the pillars of creation.
Oh, the Pillars of Creation. That's right, because
But
it's a
it's a star
two-part.
forming region
But
though.
it is
There
it
you
is a
can
star
find little
forming region.
globules inside
Yeah,
those
let's
the
let's
dust.
mm, 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 mm. This is beautiful though. Yeah, I was looking for Orion. Y'all can see that really good. So yeah,
Yeah, I
like
can see it good.
yeah, you want to explain the picture a little bit, like because even like
Yeah,
these
see,
dark clouds and well, go ahead, you got it.
yeah, this is what's called the Eagle Nebula. And this formation inside of the Eagle Nebula is it's called the pillar. They call it the pillars of creation.
Mm-hmm.
Um, but there's a lot of star formation going on inside those dust clouds, and that's usually what it takes to get star formation going. You need a bunch of dust and gas to
Mm-hmm.
coalesce. And if I don't know, can you blow that up, Miss Juju? I think on
Uh,
this picture you can see some of those going in there,
I,
if you can. But
I can't get it. Ooh, big. Where you
yeah,
want me to go? Where you want me
see,
to go?
you can go to that middle branch there around the top, right up,
Right here.
yeah, right up in there. Can you
Okay. You see
see
my
those
arrow?
are yeah? If I'm not mistaken, those are those little dots. Those are stars forming within that cloud, and
Man.
it takes an infrared telescope to see that because you know, visually we couldn't see through the dust, but that's what's going on inside of there. So you have a bunch of solar systems going on, being born inside of the tip of that. So it just gives you a good idea of the vastness, because our solar system measures, I want to say, about 3 light years. The sun's influence measures about 3 light years. So if you take an average star like our sun being born in that region there, and you're talking about an influence of about 3 light years, so it's a lot of room inside of there. So that's a lot of material to make a lot of stars and a lot of planets.
Was that Mr. Webb's question that you just answered? Did you get his question? I got it for you. Yeah, that one. And then we got one from Chief Sun Warrior, which I appreciate it. We have a new subscriber. Thank you.
Appreciate that.
What is that? Halicio? I ain't saying it right. But go ahead.
Now, when it comes to solar telescopes, they just have a hydrogen alpha or a solar filter on them. Like you can buy a solar telescope that's strictly made for looking at the sun, or you can buy a filter and put on a regular telescope. So yeah, it takes a different, you have to use a filter though, or a special telescope that's made to look at the sun, because it will burn your retinas instantly. So never ever use a magnifying glass, binoculars, or never look at the sun without any protection under no circumstances.
Right.
You never ever do that. So yeah, but they use different filters to block out the harmful rays from the sun. And who's that? Chief Sun Warrior. Can a young star absorb energy from a dying star? Yes.
Hold on for real before you answer that. So I want to say shout out to Pseudo Kill Official Kent in the building. You made it. Appreciate it.
Mr. Kick Do Low.
Kick Do Low. That's a tight name. That's a tight name.
I love it. I love it.
Name, boy.
Pseudo Killer Official.
And Immortal Truth. I see you now. I see you. But we're actually very proficient in a lot of subject matters. But we ain't gonna get into that. But I'm just saying.
Oh yeah, we
got some shows
coming well rounded.
And I wish y'all would, but y'all ain't gonna be able to. Y'all can't now. But we'll leave that alone for later. Just being a little petty.
And
I feel good. Go ahead with the question.
Peace to you, Miss Gemini.
Hey, Gemini. What's that? Always support number one, day one supporter.
Most
Gemini.
definitely.
Yeah, most she getting MVP around here. Y'all don't even know.
But next question: can a young star absorb energy from a dying star? Yes.
Yeah, binary star.
Because what you would call, and a lot of times what that leads to is what we would call a type 1A supernova. Where you would have a white dwarf orbiting its, partner. So when the other star begins to go through those phases, like going into supergiant, red giant or giant phase, when it starts to puff up, well, the gravity from the white dwarf will start to accrete some of that material.
Right.
And when that white dwarf reaches a certain mass, I forgot, it's the word they use for it. Start with a K, I can't remember. But once it reaches a certain mass, it goes supernova again.
Kilonova K, I know that. So I can't.
Yeah. Well, the kilonova is 2 neutron stars.
It's 2 neutron stars that collide. That was like our first show or whatever we did.
Yeah.
Oh, I'm sure y'all need to check out the old shows. You know what I'm saying? We still working. We always working to perfect it, but there's still lots of great information leading up to the next, which is good.
Most definitely. Now, when it comes down to a young star and an old star, for the most part, you really don't get that, because most stars that are pretty close together, they're formed together out of the same molecular cloud. So
Rasta man got you.
They
Shout out
might be
to
a different
Rasta man.
side. The Chandra, yeah, that's it. That's
Start
it,
with a
Rasta man.
C.
Appreciate you. But once you really don't find too many stars that are near each other to be different ages. Most of them are formed, pretty much in the same molecular cloud. Now you do have, like when you're dealing with open clusters, over time, those stars kind of float away and become field stars. So
Mm-hmm.
within that type of interaction, you can get an older star with a younger star. And yes, depending on the mass, that younger star can overtake what would be an older star. So that's highly possible. But for the most part, stars are pretty much the same age when they're in their cluster stages. Like I say, you have two different clusters. You have an open cluster and you have what's a globular cluster.
Mm-hmm.
The globular clusters seem to have much older stars in them.
Right.
Those stars are billions of years old. And it's said that like the globular clusters that are found around the Milky Way are more than likely captured. They weren't formed in the Milky Way. They were captured in, you know, stellar collisions with other
Mm.
galaxies and stuff. So open clusters, which is what's being formed in Orion, that's an open cluster. Those stars over time, they're not gravitationally bound to each other like the globular clusters. The open clusters, they kind of, those stars just kind of go off on their own, do their own thing, and become what we call field stars, like our sun. Our sun is what's considered a field star. So in that instance, you can get a younger star accreting from an older star. So those are a couple of ways that I know of in that aspect. Let's
That's
see what we got up there. What's that astroseismology? I'm not sure. Is that some kind of
Mr. Webb.
starquakes or something? See what that is.
I wanted to get through a few more things before we keep asking
Okay.
questions because we got
Yeah.
more information to give y'all.
Oh, we sure do. I'm tripping.
Yeah.
I love answering these
Yeah.
questions, though.
I mean,
We're going to
so
have to do an all questions show. We're going to have to do a show with just
or
answering questions.
so y'all hold on to the questions. I see you, Mr. Webb, Mr. Webb's with another question, and shot Chief Some Warrior. Hold that question for a couple minutes, and we're gonna get through some stuff, and we can get back to it, or we just want to kind of finish off. And plus, we want to have room because we have our Black History Month tribute. And we like finna double it up for y'all. We got 2 apiece, and I think y'all gonna be very pleased with what we got for y'all. Not only that, and just a little quick commercial break, but make sure you look at the description box. So what I have given you, what you're looking at here right now, is actually from NASA, and it's star types. But the other beautiful pictures where where it shows the nebula, the pillars of what again? I always forget
The
about it.
pillars of creation.
The pillars of creation.
Mm-hmm.
I'll come back to that, but that is basically a catalog of all of Hubble's pictures, okay?
Mm-hmm.
And this one, if I got the right one, this right here is so super fly. So this is from NASA, and this is its sky map. And I'll play with it a little bit, and I won't go full screen, but I'm going to demonstrate some stuff. And the reason why I have all this in the description box, just go in there and collect them links, copy them links, because these are things that you
Yeah.
do with your children. How fun is this? So this is sky map. You can make it full page, but I'm not going to do it right now. I'm going to go real quick. But it's the bluest stars, the yellowest galaxies, the pink is nebulas. Then you got what I say, exotic, and then exoplanets, right? So the pink is a nebula. So you push on it, and then boom, the nebula, and gives you all the information.
Yeah.
How dope is that? Push on it. Boom, star clusters. Like this I literally spent like an hour playing with this last night while I was
Mhm.
researching the show and putting it together. This
Yeah.
was what I was doing. Like, how amazing is that? So beautiful. So I'm just telling you all, like, when we do these shows, we leave all these tools for you. There ain't no
Yeah.
secrets. We ain't hiding none. Everything that I've read from, every where that I got the information from, I gave it to you. So again, if you ain't watched the show, or if you missed it last week, go to last week's show or the week before, because that's all gone. And go in the description box and get all the sources, and voila, and then watch the show. You feel me? Because I'm funny and kind of cute, but that's for another story. This is awesome. So yeah, this is Sky Map, y'all. Yeah, I won't go, but this is Sky Map by NASA. Just click that link and it's yours. All right. Um, so I wanted to get back a little bit into star types real quick. Just want to get through the information and then we can play. We can really have some fun, right? But the star types. So I think we left off with main sequences and red giants. We got into red
Mhm.
giants. Um,
Yeah.
and I think you're about to go into white dwarfs. In
Mhm.
am I sharing my screen? I'm not, but I'll get to it. So even the picture that y'all saw for the start of the show, I got that from the catalog. So all this time,
Mhm.
I didn't realize I can pull from the catalog, but that's what happens when you research. Like eventually you get it and you
Mhm.
don't find it, right? So yeah, I found the mother lode. I found what I did is I cut out the middleman and I found the plug. That's what it was.
Mhm. Hey, that's what you got to do. Get your plug.
I'm gonna stop playing with y'all. I'm sorry, any parents out there. It's the plug for bread. Okay. Don't be so uptight. Okay, let me stop. Oh god, I'm having too much fun. This is hilarious. But go ahead, get into the white dwarfs. Tell us what the white dwarfs is. And by the
Okay.
way, the sun, it is a dwarf star, y'all. And that's
Mhm.
another categorization. So after you finish this, we'll get into the other categorization. Um, um, and yeah, I'll get that for you. But talk about it.
Okay, now with the white dwarfs, it's not an actual star. It's
Mm,
the remnants of a star. It's the
oh,
leftover core from
mm,
a star like our sun. So what it is mainly made of carbon, some oxygen, maybe some helium, but that comes after fusing the hydrogen, after the main sequence. And like we said, there's it's each level of fusion, it leaves a shell around the core. So our sun, like I said, it will stop, it's gonna run out with helium. And whatever's forged when it run out is what's gonna be left in that white dwarf, which the ones that they find are mainly a bunch of carbon, oxygen, and a little bit of helium. So that's going to be the fate of our sun, which will be after the red giant phase. So when it goes through the red giant phase, the outer shells of gas are just going to basically float away. And that picture you showed earlier of the Helix Nebula, that's an example of a planet. It's called a planetary nebula. So there would be
mhm.
a white dwarf once all that gas and stuff has dissipated and floated off into space. There'll be a white dwarf left. So that's basically the process that brought about Sirius B.
Oh,
That's
right.
basically that same process. And it's a
Fat.
white dwarf. It's not very luminous. You can see it with, telescopes and stuff because it's hot. It's still burning, it's hot from all the fusion that had taken place. But I don't know anyone that has ever seen one with the naked eye, so don't get that confused with what I say. You can see it with a telescope, but not
Mhm.
with the naked eye. And that's because it's not fusing any hydrogen. It's the only light would be from the heat. So it'd be, heat light, mainly visible in infrared. If you had an infrared telescope, you could see you can see them all over. You know what I'm saying? But that's what it'll take. And the sun for Joe, our sun it's an average dude. It's a small star. There's stars that are much more massive than our sun, but the lower mass stars are more prominent. So you have more red dwarfs than anything. And there's the more massive the star, the less prominent it is in the galaxy. So the O-type stars make up only about 1% of all stars in the galaxy, and you're talking about anywhere from, I want to say we got about 1 billion stars in the Milky Way, estimated. So 1% of those are O-type stars, the biggest and most massive. Now, like I said, stars like our sun. Can you pull up that Hertzsprung-Russell diagram, Ms. Juju?
Mm-hmm. I shall can.
Stars like our sun, it's not massive enough to forge anything past helium.
I just remember this is a neutron star right here. I know.
Yeah.
I'll get the Hertzsprung-Russell for you real quick now. Let me go. I got pictures for days. I got visuals for days.
To Joel, no. That question there, because this will go back to a question we had earlier too. The habitable zone. The habitable zone around stars is going to vary by the mass and the heat of stars. Mm-hmm. So if our sun was larger in the position it's in right now, no, we wouldn't be able to sustain life here on the earth because it'll be too hot for us. You know, we evolved through a calm sun. You know what I'm saying? Our human evolution took place during a calm sun, is what we know of to be calm. So when the sun goes through the red giant phase, Earth is going to be doomed. You know, we're going to get caught up in that. The sun is going to swell up, so that means the habitable zone moves farther out. You know what I'm saying? So it's estimated that we're not going to make it past that. So each star has a different habitable zone. And it, like I say, it depends on the mass of the star and the heat. I think it's estimated around an O-type star, the habitable zone would probably reach way out to Jupiter. Mm-hmm. You know what I'm saying? That's the area where it will be cool enough to have water and ice on the planet.
Right.
Any further out, now you got an ice planet. Any further in, now you got a planet of steam, like Venus. See, Venus is a tad bit too close to the sun. So we got, let me see, Joel, we got about 5 billion more years left. They say the life of our sun is about 10 billion years, and it's halfway through its life. So we got about 5 billion left with our sun. Okay, on this Hertzsprung-Russell diagram, you see that middle line there, that's the main sequence.
Where most of the dots are.
Yeah, that's any star that's burning hydrogen. No matter what the mass of it is, it's fusing hydrogen. Mm-hmm. Now, these other lines are the stars after they move off of the main sequence. So they're not burning hydrogen anymore. And each star goes through a different phase. Well, each classification of star goes through a different phase. So this chart right here is vital. It is vital. This is where all of the information we know about stars is culminated in this one chart for understanding. So if you can learn this chart right here, You'll see what happens to the O type stars, the B, A on down to M. But each one of them goes through a different type of phase, a different, you know, like I said, the O types, they're going to be supergiants. And
Mm-hmm.
an example of a supergiant would be Betelgeuse, the
Oh,
brightest, reddest star within the Orion constellation. You know, it's
yeah.
hard to miss. So
Beetlejuice is beautiful.
it started out as a O type star, and now it's going through its dying phases. So it's swelling up, and it has become
Duller.
a super red giant. Hmm.
I was gonna say duller because I was reading something where it's saying like the luminosity of Beetlejuice or something like that was changing or fluctuating.
Yeah, it's a variable star, so it gets
So it's
brighter,
variable. Yeah, yeah.
and you know that's classification of a certain types of stars. They're called variable stars, which we'll
Mhm.
get into when we get into the cosmic distance ladder, how they measure distance.
Mm, that's gonna be next show, right?
Yeah, that'll be next week. We'll get
So
into how they use these stars
yeah,
to
to calculate
measure
things.
distance
Hmm.
in the universe.
That's dope. So
Yeah.
one more piece that I wanted to get into about classification. So we've told you all about spectral classes, the OBAF, GKM, and L, or my MKG,
Yeah.
FAB. Whatever. So I'll be out there. But we told you all about that, right?
Hmm.
Going to the hottest to the coolest, starting with O being the hottest. And then we told you about 10 spectral types, right? And these are
Hmm.
numerals, and it's 10 it's 10 spectral types. So 0 to 9. 9 being the coolest, 0 being the
Hmm.
hottest. So our sun is G2. So that means it's on the smaller side, kind of in the middle, but a little on the smaller end of
Hmm.
the middle. And also it's a 2. So in its spectral class, it's one of the hotter stars in its own special class. So then
Hmm.
there's one more piece to the puzzle, and this is how they name the stars or the actual classification of the star. And this is a Morgan Keenan system. So now they label them as the largest and brightest classes of stars have the lowest number in the Morgan Keenan system, and they do it by Roman
Roman numbers. Yeah.
numerals, right? So
Hmm.
you will start at 1A, which is a bright supergiant. Then you got 1B, is supergiant. Then you have 2, a bright giant. Then it goes to
Hmm.
3, which is a giant. 5 is a subgiant, and V, a main sequence or dwarf.
Hmm.
So the whole classification for the sun is a
G2V.
G2V. So yeah, so it's giving you, the spectral class, the spectral type,
Mm.
and then it's a luminosity classification.
Look
So
at you, Miss Juju. Shit, that's what's up. Look
yeah,
at you.
boy, I was doing my thug this on my
Yes,
bitch
you
my
were.
head. Yes,
That's what's
sir.
happening.
Ah, you like that? You like that?
I love it. I love it.
I'm just playing, but I think that's dope. I'm telling you, y'all, I'm
It
the student
is.
here. So every time we do this show, this is like this like my test. You know what I'm saying?
Hmm.
Sometimes it be a little bit of pop quizzes in there, but yeah. Shout out to Unbiased Truth that hit the building. Rasta man. Rasta man, you almost like a little co-host. I like that. Like definitely very knowledgeable, but I already know. Who
Oh
we
yeah.
came in here? Fine Tan. I think he came in the door not too long ago. At least I think I saw somebody say hey to him. And if you didn't, then oh yeah, there you are, there you are, there you are. So yeah, and that's kind of where I wanted to get or finish up, and we'll answer some more questions. If that's what y'all want to do, that's fine for me. But did you want to go through neutron stars, red dwarfs, or brown dwarfs real quick? And then we'll get to some questions. We're going to do a few more questions, and then we're going to do our Black History Month honors,
Yeah.
because that's the most exciting part, right? To actually
Yeah.
showcase people that are in science doing this type of work or anything engaging in the work in scientific inquiry, whether it's in astrophysics, whether it's in engineering or whatnot. Like
Hmm.
Black people, African Americans, Africans in the diaspora, like we're participating every day, all day, and there's lots of us doing it. So it's kind of, I'm not gonna just say mine. I think we both share this sentiment. Our personal mission to eliminate. We shutting down the white man's science. There's no more of that.
Killing it.
Science is a international a conquest. Pretty much, it's a human invention, but of course, those humans started in Africa. And then I got a super big surprise. We're gonna get to some West African stuff. Oh, let me stop. I'm so excited. Yeah, that's an energy from because I'm excited. Like I was
Oh
like,
yeah.
oh, we doing this, and that because Anthony, I don't even know why you just put that video in our little section. That video was supposed to be in the main section, like share with everybody because that video was fire. But I won't spoil the surprise. But we'll get back into talking about the different types of stars real quick, and then we'll ask some questions and get into our tribute. So y'all know I love the pictures. So let me give y'all this beautiful picture. At the neutron star, you didn't get
Yeah.
that yet, did you?
Well, okay, the neutron stars would be pretty much like a cousin or a big brother to a white dwarf. It's it's not an actual star. There's no fusion going on, but it's the core of a more massive star.
Super
And
dense.
yeah, very dense. Now,
Mm-mm-mm-mm.
neutron stars are created in supernovas. You
Mhm.
know, you can, depending on the mass of the star, you'll get a neutron star in the result or a black hole.
Right.
So the neutron star is very, very dense. It's estimated to be about the size of about 12 miles in its radius of about 12 miles, but it's all that initial mass, or all, not the initial mass, but the majority of the initial mass from that star is crammed down into that
Mhm.
12-mile radius. So that makes it very, very dense. And we still don't know exactly what they're made of or their composition, but we do know that they're very, very dense because they warp space around them, not
Mhm.
as critical as a black hole, but you know, they do warp space, and we've seen collisions from them, so they do put off gravitational waves. And there's different flavors of a neutron star. You have pulsars, you have magnetars. You know, a magnetar is a neutron star with a crazy magnetic field and a spin that's out of
Yeah.
this world. It's
It's
a very rapid spin.
a spin that's precise
And,
and measurable. That's I why do I remember that? That's all I
hey,
remember about a
because
pulsar.
yeah,
Precise and
it's good
measurable.
stuff. You know,
Yep.
you remember the good stuff. You know what I'm saying?
Mhm.
It's good stuff.
But I'm
So
just saying that was one of the main things when we talked about pulsar stars like 2 shows or maybe 3 shows ago, when we were talking about that, what we call it, it's a stellular, because
say that again.
they use the stars to calculate something. But they're considered like the lighthouse of the galaxies. It'll come back
Yeah.
to me in a minute, but I want to break your bill. Go ahead.
Well,
Sorry.
those are like the pulsars.
The
And
pulsars. Mhm.
what that is a rapidly spinning neutron star with beams shooting out of the poles. And they're rapidly spinning. So if you're in that line of sight, you're gonna see like a blip, 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 and they're very accurate. You know what I'm saying? They're very accurate. So that's what neutron stars, you know, those are the phases of a neutron star. Now, red dwarfs and brown dwarfs,
This is a red dwarf on the screen.
is it?
Yeah.
That, that's kind of bright to be a red dwarf. You sure
It's
that's a red dwarf?
That's what it say. This
Mm.
is our closest stellar neighbor shown here in
Yeah.
this Hubble image
Okay.
is a red
Proxima
dwarf
Centauri.
Proxima Centaurium,
Yeah.
just over
Okay.
4 light years away.
Now, those red
Yeah.
dwarfs, they don't shine in the visible spectrum.
Mhm,
You pick them up in the infrared.
mhm.
So you won't see any red dwarfs on none of my pictures because I'm shooting in the visual. But with the infrared, yeah, you'll see it shining pretty bright because of the heat. Now, it's very, very small for one. They're very cool. If you look at that Hertzsprung Russell They're at the bottom right hand side
Oh.
of the chart. But yeah, that's actually the closest star to our sun. I
Mm-hmm.
think it's about four. Is it what, about 4 million? No, about 4 light years away or something
That's
like
what it
that.
said. Fort Light years away from
Yeah,
mm-hmm.
it's very cool, and it has planets. There are planets around them. They find planets around red dwarfs. I think another system would be TRAPPIST. I think it's the TRAPPIST-1 system that they're doing a lot of research on.
Mm-hmm.
But yeah, that's basically in a brown dwarf. It's it it's not fusing anything. They're
It's
very
just
very small. They're not too much bigger than a planet like Jupiter, but it's composed mostly of lithium and a little
it's a
bit of
brown dwarf.
hydrogen.
This
But
is a brown dwarf, but this is an artist rendition of it. Okay.
yeah, and there's a scientist. I give y'all a Black History bonus. A guy named Gabor Basari. I think it's Gabasiri, I believe.
Mm-hmm.
But he does a lot of work, real good work on brown dwarfs.
Mm-hmm.
So that's one a gentleman that we can look into to study brown dwarfs. But yeah, they're not fusing any hydrogen. Matter of fact, the brown dwarfs are mostly made of lithium. Their composition is a lot of lithium. So there's
Mm-hmm.
no fusion going on, but they are bigger than planets, but smaller than stars. So they kind of teetering.
In the
They could
middle.
be,
They
they have,
trying hard.
yeah, they on
They
the
wanna
fence. They
be
don't know what they want to do.
somebody.
you
They
know.
trying to be somebody. Um, yeah, we have a few more questions. I'm sorry, did I cut you off?
Oh no, 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 no.
Mr. Webbs, yes, yes, yes. What African diasporans beings has helped with the support of understanding of stars, suns for inspiration. What kind of inspiration do you mean? Because actually, that's part of our show, and I'm not going to spoil it. So you're just going to have to wait for the surprise. One more question.
hmm Let's
Um, did the
see.
did the Big Bang burst stars that gave life as we know it on this planet? The reason I asked because the human body is created out of all the elements that created a star. Am I reaching? No, we talked about that, but
Yeah.
go ahead,
No,
repeat yourself,
the
Anthony.
the Big Bang, the hydrogen, a little bit of helium, and a smaller amount of lithium was created in the Big Bang. So the hydrogen is what all the other elements are created from. So basically, you can say that all of the other elements are a version or a rendition of hydrogen. So in order to get all the elements that made us up, you had to have a bunch of supernovas to go off first. And the very first stars, which were labeled as population 3 stars,
Mm-hmm.
those are the very first stars that were created after the Big Bang. So that was mostly pure hydrogen. And the fusion that went on theoretically in these stars is what led to what we would call population 2 stars or second generation stars. And in the fusion of that hydrogen going all the way down to iron, you have different things that's going to take place, like neutron stars, or, depending on the mass of the star, white dwarfs or whatever. Well, when those first stars, the population 3 stars, which were mainly pure hydrogen, when they went supernova, those elements that they created were dispersed throughout the universe, formed molecular nebulas, and over time you had second generation stars which were formed from the nebulas from the first generation stars. Now you got different that molecular cloud that formed the second generation stars. It has more metals in it. It's not quite as pure hydrogen. So now you have other things, elements that are mixed in those clouds. Now you have stars forming from them. Hydrogen still burning or fusing, but you have other trace elements in those stars. And when those stars go supernova, now you have all the trace elements and the new elements that's being created in that star is being dispersed throughout the universe. And the same thing happens again to form our sun, which is known as a third generation star or a population 1 star. It's backwards. You know what I'm saying? When you say population 1, you're speaking of younger stars. Population 3 are older, or the first generation stars. So yeah, like what you got up there now, that's what's going to happen to the sun. That's a planetary nebula. Now, when you look at something like a Cassiopeia A, can you pull that up, Miss Juju? Cassiopeia A.
Ooh, I don't know if I can pull that up. Let me see.
Can you Google it?
Hey. How you spell it?
CASS. I think it's 2 S's. IOPIA. Let's see.
The same.
But that's a supernova remnant.
Okay, hold on. Let me see if I can find it like this. No. Is there another one? It's only giving me Carna, Carolina Cluster, Catwell, Cat's-Eye, Carnum Nebula. What is it again? Tell me what it is exactly. What type of star?
CASIOPEA.
That means you ain't got it.
Okay. Can you well anyway, Cassiopeia A is a supernova remnant.
Okay, hold on.
And you can see the difference in the two.
It's called Cassiopeia star?
A, just Cassiopeia A, the letter A. Cassiopeia and then the letter A.
Cassiopeia. Ooh. 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 I got you. Oh my God.
That's beautiful, ain't it? You
see? Yes, sir. Look at God. Oh, wow.
Yeah. See, now that is what a supernova remnant looks like. So this is what happens when the star explodes. Now you see all these different colors. All those different colors correspond to a different element or hydrogen at a different temperature, which, you know, forms different elements. You know what I'm saying? So that's how those elements are dispersed throughout the universe. I mean, throughout the galaxy. So you can take one of those and then you have another one to go off nearby. And then you get another one to go off nearby. All those chemicals are gonna form a new molecular cloud. And gravity is gonna take over and start coalescing, making the molecules coalesce to form other stars. So that's how all those elements that we find in our bodies, that's how it happens. That's why I was saying earlier that it's estimated that over 60 supernova were, it took over 60, or the composition of our solar system can be found in over 60 supernova. I guess that's a better way to put it. But this is the remnants of a supernova. That's mostly what and they come in all different shapes, the supernovas. But the planetary nebulas, they're pretty round. They have a little shape, you know, little difference in shaping, but for the most part, they're kind of, you know, round. But supernova remnants, and they look all kind of, I mean, it'll be crazy if you just look at supernova remnants. You never find two alike. They're all different. at least all the ones that I've seen. You never find two that are exactly alike. So that's pretty much what happened after the Big Bang. You know, that's how those elements that make up us, that's how it gets to us. You start with the population 3 stars, mainly hydrogen. They explode, spit chemicals out plus hydrogen. Generation 2 stars, cycle starts over. Same thing happens. The molecular cloud coalesce, come off the main sequence, go supernova, and then it disperses all those elements and then forms another star like our sun. And it's going to happen to our sun. It's going to disperse, and all those elements are going to mix in with another cloud and form another generation of stars. And it'll probably keep going and on and on. So, yeah, I hope that answered your question at all, Immortal.
Okay. So I'm gonna start sharing some surprises, and then me and Anthony are gonna do our Black History tributes, and then perhaps we have time to answer a few more questions. But what I'm about to show you now. So again, the link is in the chat. Did I take it off? Yeah. The link is in the chat, and it's actually a video. I gotta find it for y'all real quick. 1 second, because I need to show you this. It's a video. Anthony shared it in the Discord in no, that's not it. And I watched it and I was blown away. So what took place in this video actually took place a few years ago in 2021. It's not there. Sorry, just a little delay because I really want to get this for you all. And it had to do with, not playing. I just wanted to give you the site though. So I'm going to show you the site. Of course, I'm not going to play it, but you can grab the link out the description box, and please watch this with your family. But if you see at the bottom, well, at the top is Star Chasers of Senegal, full documentary. And I'm thinking this is very new because it's funny. Anthony dropped this like the day before yesterday. I watched it last night and I've been sending it to everybody. And then when I woke up and went on YouTube in between researching and setting up the show, I saw that Sean P or Sean Annie Harret had did this huge post today about this, or was that last night? And I was saying, oh yeah, I'm gonna talk about it. He's like, oh, Ben did the presentation. I was like, I don't remember it, but there were times where I was, kind of like absent in the midst. So I might have missed it. You feel me? But nonetheless, it's phenomenal. And with that said, I'm going to get into my first presentation. But first of all, the reason why I wanted to show that because it speaks on a gentleman who is basically an astronomer. He is from Senegal, an indigenous African, and he's doing some phenomenal work to increase not only scientific literacy in the country of Senegal and surrounding areas, but he's been very actively engaged in some major scientific endeavors that's been going on in the last few years. I'll tell you his name, but I want to share you some of the discoveries that were made also during this his quest for answers on some things. So what you see over here to my right, I don't know if that's to your left, but this is the west coast of Africa. And if I can make this bigger, which I can, this is pretty awesome too. That's cute. These are the sites where these items are found. And what these items are found, and by the way, this is the Senegambia area. So you got Senegal and Gambia. These are the countries that these stone sites are bordering. But you have these stone hedges. And it's not one site, it's four sites. Um, and it's pretty phenomenal. And so, as this gentleman, which I'm going to get into in a minute, was searching for answers and dealing with some scientific conquests that were concerned with NASA. And this gets to the point, I think, Immortal Truth in the chat, speaking about finding the beginnings of life on Earth. Well, they're actually doing some studies right now to try to help us explain the origins of our particular galaxy. And how they're going to do this is by studying some of the asteroids that were created out of, um, I guess, the star formation and our planetary system coming to fruition. Um, so that's one thing. But all these links, again, in the description box for you. And the gentleman that I'm speaking of is none other than Maram Kari. Maram Kari is that man. Let me tell you. Um, Let me just get him up here real quick. Yeah. This is Maram Kari, ladies and gentlemen. Let me just tell you about Maram Kari. Not only is he part of the documentary that I just showed you all, and it speaks a lot about his scientific endeavors with NASA. He runs several programs, improve scientific literacy, but he also understands how, Senegal, not only is it French colonized, but it's very much a Muslim population. So there's some things that are kind of holding the people back because of the rules and laws of the Muslim religion, being that it's a Muslim state, so to speak, a country. So he's also trying to influence some of the leaders, the Muslim leaders who make all the calls on uh, adding scientists or giving them tools to help them do certain religious acts more efficient. And one of them had to do with Ramadan and the ending of Ramadan, because you have to be able to observe a crescent moon with your bare eyes. Like, you can't use any technology. But on this particular occasion, he was speaking with the leaders. They said you can use binoculars. And so when they use binoculars, that's a bit of technology, because he wanted to use a telescope. They were able to see it better and quicker, more efficiently, right? And so people don't understand Ramadan is a whole bunch of fasting or whatever, but it can kind of slow progression up because of the religious rituals, is the point. But then he also realized that there were other Muslims that were actually using some scientific elements and had been since one of their leaders some years ago. So he tried to follow the path of this leader and realized that Senegal actually, does have some has been following science. Remember, this is a really big country. You have different religions, sects. And so he went on this journey, went to Istanbul, and kind of follow the path of um, um, uh, uh, Muslims in science, so to speak, right? Fascinating movie. So Mr. Marine, Maram Kari, is a system engineer and astronomer. He was a commander of the National Order of the Lion. Maram Kari became the first Senegalese to have his name attributed to an object in the solar system, with the designation of the asteroid, and it's 35462. Um, Marin Kari by the International Astronomical Union, um, in May 2021. He's co-founder and current president of the Senegalese Association for the Promotion of Astronomy. He's also managing director of Africa Space, a company specializing in strategic support for African states in the development and implementation of their space policy, and was recently appointed the director general of the Senegalese Agency for Space Studies, and lots more things. But one of the major things in what was spoken in that movie is his assistance, his cooperation in coordinating three important NASA missions in Senegal to observe stellar occultations. And literally, a stellar occultation takes a matter of seconds, like 3 seconds, but it gives you a plethora of information. This information is going to be vital from the spacecrafts they're going to send in space to study this particular asteroid to figure out how did our planetary system, came to be what it was? How did our solar system came to be what it was? So it is quite fascinating. I'm not going to get into the readership, but again, the links for Maram Kari, that movie, and the Wikipedia site, and you can also look up UNESCO for the stone sites in Senegambia. That's Senegal and Gambia. And there are 4 of them if you want to do more or share this with your children. So yes, there are Africans that are getting involved who are actually actively engaged, who are not religious fanatics and want better for their country. Like I keep telling people, Africans ain't looking for no African spirituality like we're trying to do over here and move backwards. They want science, they want technology, they want the best of the best of medical medicine and everything. So, it's just to show that we should not be spinning a narrative of a continent with many countries that's looking to move and push forward and want to be on that competitive world stage. So for Black History Month, we honor and we salute you, Maram Kari. And yeah, thank you for all your work. And this is someone who's actively engaged right now. So yeah, shout out to Maram Kari. And I'll let you do your first one, Anthony, and then I'll do my last salute.
Okay, I want to introduce you all to a gentleman. He's not necessarily a scientist, but he was vital in the role in getting, I guess you could say, the final stretch of James Webb telescope. Guess you could say getting it into space. James Webb Space Telescope ran into a lot of problems here late. I mean, that was over a 20-year endeavor, to get that telescope into space. In the last few years, they were about to pull the plug because over budget and all that good stuff. So this gentleman, Greg Robinson, they brought him in, and he cleaned up the program and he got everything back on track and was able to lead to the discoveries that we're getting today. So this gentleman here, he was more on the business side of it, but he was the director of the program. Mm-hmm. And like I say, he got it back on track, and you can basically say he holds a lot of responsibility in what we are getting from James Webb today. Mm-hmm. Because like I said, the program was way over budget. It had taken, for some people, actually too long. Because, they started designing Webb right after they got Hubble, after they launched Hubble, which was back in the late 80s, early 90s. So it was this gentleman here that came in and, got everything back on track that led to all the discoveries and beautiful pictures that we're getting today from Webb. So I want to salute this gentleman here, Greg Robinson, for being a linchpin in all the discoveries and, information that we're getting from James Webb. So salute to you, Mr. Greg Robinson.
Absolutely. Salute to the HINC of
yeah, a HBCU graduate as well.
HBCU graduate, but no, I was talking about that Joe Clark.
Oh yeah.
Let me stop. But yeah, I just wanted to kind of add on. So I don't think people realize that the time and the effort it takes to do these scientific endeavors, and they have problems. So on the technical side is one thing, but on the business side, you got to be able to handle those problems efficiently, right? Mm-hmm. I mean, budget, right? You have to be able to plan. It's almost like he was the ultimate project manager. So, helping to find solutions, because it's not like you just sit in the office, like you got to help them figure it out. You get what I'm saying? So, when that plan got stuck, he got it back rolling,
Yep,
going.
got
So
it back on track.
yeah, so everything we've been showing you is mostly, pictures from the James Webb, especially those really fantastical pictures. Those are more or less James Webb photos, okay? So don't be fooled. So yeah, a lot of gratitude to this man. And when you said you were doing him, Anthony, I was like, yes, because actually when PK in particular or the James Webb first came out, and we were talking about it. I was really looking for those people who look like me who were actively engaged and participating. At the time, I was just looking for the scientists, though. Not so much. We got a few Puerto Ricans and whatnot, but he was one of the people that came up in the main one. And director, I was like, okay, like he is really doing that work, and that's a very important job, just as important as the scientists and all the technicians or whatnot. So shout out to this gentleman.
I mean, just imagine, like I said, the Webb was a 20-year endeavor. He came in the last few years. Just imagine if he wasn't able to accomplish what he did, the careers that would have been wasted if they had pulled the plug on Webb. You know what I'm saying? People have been working on this thing all their adult, their professional careers, and it would have just been pulled with, nothing to show for it. You didn't work all this time, half your adult life for nothing, So a lot of people, whether they realize it or not, owe him a very big thanks. And I'm sure he gets it. You know what I'm saying? I'm not saying that nobody, knows him, because he's a well-known man when you get down into James Webb. His name is going to come up.
Right.
So big ups to Mr. Greg Robinson.
Big ups, Mr. Greg Robinson. You did that. That's what I'm talking about. So we doubled up today, okay? Because it's so many people I want to cover when we talk about, combating white man science and showing how we are actively engaged in this. But y'all know I could not. I couldn't forget this one. I couldn't forget it. Like, how would I forget that, right? Like, who does that, right? So,
hey, Black history in the making that we can actually,
in the making,
we can actually relate to. You know what I'm talking about?
We know her. I get to talk to her. Like, every time I text her, she texts me right back. Anytime I want something, she give it to me. Like, she's actually a superstar, and I don't know if she know it, but that's how I look at her. Like, I'm in awe all the time. And if I can remember correctly, because I asked her, for a bio, give me a bio, you want me to say. You feel me? That because you want people to know it. She'll be very efficient in it. And I remember, I think I remember. If I'm wrong, Dr. Mayat, please forgive me. But I just wanted to salute you and honor you. But if I'm not mistaken, she is a PhD in electrical engineering. And I think she was one of like the 13th Black women to get a PhD in electrical engineering. But if I'm wrong on that, I'll correct myself on the next show. But that's still a phenomenal feat. Like,
yes, indeed.
I don't know what to say. So I'm gonna read this bio for y'all. Y'all ain't finna play with my sis. But ladies and gentlemen, for those who don't know, that's Dr. Oya Mayat, Dr. Deanna Bailey to her students at Morgan State. Or either way, but she's very transparent and we know her. So Dr. Oya Mayat is a native of Baltimore, Maryland. Be more, you already know. That's Bobby Banger homegirl. I think Joel in the building, Sheffrin, all them from Baltimore. So y'all know how it is. And they speak this language called Baltimorean. I always get on them all the time. I'm trying to translate for other people. But she do better than others, but yeah, we're not gonna get into it. But with Bobby and what is it? They call a dog a Doug. But anyway, she is also she is a U.S. Army veteran who received her undergraduate degree in electrical engineering from Morgan State University. While serving in the military, y'all, she continued her education at Morgan, eventually receiving a doctorate of engineer degree. Dr. Mayat is currently a faculty member of Department of Electrical and Computer Engineering Department at Morgan, where she utilizes African-centered methodology, or a type of pedagogy, y'all, to instruct her students and create a culturally affirming classroom. And I just want to tell y'all something. So even though she gave me this, I did go and try to look her up, from the Morgan standpoint, and they had some other resources because you have resources like what the students can write about the professors. And
Mhm.
when I went on that, yo, like it wasn't like one bad word said about her. Like she's phenomenal. You know what I'm saying? Like I ain't finna cry, y'all. Like literally, I
Mhm.
just almost want to cry. Like this whole session speaking about Maureen Kari and her, like it
Mhm.
just filled me with joy. I don't know if y'all understand. That fills me with joy. Because these are things that are affecting our children. These are things that are gonna affect us in the future. And
Yeah.
sometimes you feel down and you feel like we're doomed, but there are people doing the work, so we can't give up. Like I'm literally about to cry. This is so beautiful.
Yes,
So
indeed.
her research focuses on determining the best pedagogical strategies. That's that pedagogy word, y'all. That's the art of teaching for those who understand that. I use that a lot. So that's important. Um, pedagogical strategies, African American STEAM learners. Additionally, she designs, implements, and directs pre college engineering programs based on her methods. Dr. Maya and her team have been awarded over 1 million in National Science Foundation, the NSF grants to increase the interest and participation of African Americans in STEM by combating systematic racism with STEM
Mhm.
education. And for those who don't understand what STEM is, that's science, technology, engineering. Sometimes you add the A for arts, and mathematics, the M. Dr. Maya also aims to reconceptualize engineering for African people in the 21st century and aspire the utilization of engineering for the liberation and the advancement of African people. Y'all, I better
Mhm.
not cry. Dr. Maya is the founder and director of Edumame Productions, and I'll make sure I get that link of Edumame for those who don't know for the next a show. I was running out of time for this show, and it was a bit of trying. We were supposed to start at 7, but I was actually wasn't feeling very well. Was feeling faint, so I had to give myself time to like eat and get myself together. So yeah, that's probably why I'm high energy because I almost couldn't get to this point, and I really wanted to get this show for you all. But I will get Edamame Productions, a company that creates educational programs designed to cultivate the consciousness. Oh man, B. Timeout. Consciousness. I think I said character. Um, sorry, consciousness, character, and capabilities of African children, and to affirm their identity, intelligence, and potential. The company offers three programs. It's Meltrek, a multimedia program that teaches children about the history, culture, and achievements of African people, then one that Pseudo Killers definitely supports all the time with Uhuru Academy, Baba Amin, Conscious Ingenuity, an African-centered science, technology, engineering, art, and mathematics program. This is the STEAM, and the a Sofo Training Academy, a program jointly created by Ed, Ed Aname Productions and the Pan African Liberation Movement that focuses on manhood development and teenage boys. Dr. Maya, also the founder and host of Truth to Power Talk with Dr. Maya, a platform that's committed to informing and connecting African people around the world, elevating the voices of African educators, researchers, scientists, humanitarians, and entrepreneurs, and combating online misinformation and disinformation. And for those who don't know, Dr. Maya is an official pseudo killer. Shout out. Her platform has been viewed by nearly 1 million people. My God, this lady is amazing, y'all. Dr. Maya has been featured in two documentaries, and we already know Butt Breaking, a film about historical sexual exploitation of Black people globally, and The American Maroon, a documentary about African resistance in Americas. Dr. Maya is the recipient of numerous awards. So she just recently got this award, y'all. If y'all don't follow her, the UNIA, which was created by Marcus Garvey, the ACL Community Service Award. Also, this is the association, the American Society for Electrical Engineers. I'm sure that's what ASEE means. I didn't get to look it up, but I'm pretty sure because I'm good with my acronyms, especially with my scientific ones. Especially for African Americans, because I have friends that are involved in those, and I try to educate people in those because the ASEE and these other organizations, a lot of times they provide scholarships to children or people in college trying to seek out
Mm-hmm.
particular type profession. So that's why I always be mentioning like the ASE. What's the other one? The National Society for Black Engineers. You got a association for Black psychologists. I think I put it in the description, and there's many more. I usually try to share the ones for African Americans for sure because of the marginalization of us, but they all are beneficial. Okay. But she got the honorable mention award in that. Also, the Morgan State University Office of Academic Affairs Creativity Award, the Inspire Her Award, B1 Educating Award, Black Power Award, Tau Beta Phi Engineering Honor Society, Lockheed Martin. Do y'all know who Lockheed Martin is? Scholarship recipient, Society of African American Military Engineers Scholarship recipient, and Distinguished Honor Graduate of the U.S. Army Finance School. So, that's a resume, and she's still building the resume. Like, that's absolutely phenomenal. So for Black History Month, we salute, we honor, we thank you, Dr. Mayat. You are truly an inspiration, one of the most beautiful individuals I've ever encountered in my life, and your work is phenomenal. And I could not have not done this show and not have did a tribute to you. So thank you, thank you, thank you. Yeah, so I'm gonna go off camera so I can wipe my nose because I really did like tear up a little bit.
I want to say to Dr. Mayat as well, thank you for everything you've done for this community. If I can't speak for no one else, but you have a very big fan in me.
Yeah.
So, it's nothing but appreciation for you and the work that you're doing for our community. That's major.
Major.
And if y'all hadn't, y'all need to go subscribe to her channel.
Facts. Thank
She
you.
has
I'll be slow.
some good shows going on over there.
Oh boy.
And okay, I want to get into my next one. Young lady, her name is Beth Brown.
Dang.
Let's see if we can get that pulled up.
Give me a minute. I got you.
Okay.
I got you. Just give me un momento.
This is another example of one of our good sisters who has played a vital role and made some history in the field of astrophysics. She just want to read a little bit about her. I'm gonna start when she was young. It says, while she was in high school, Beth visited an observatory for a school assignment. There, she looked through the telescope and saw the Ring Nebula, which is one of those planetary nebulas we were talking about earlier.
Mm-hmm.
And it was all she needed to get hooked on astronomy. She's quoted as saying, "I thought that was just so cool to know that I was looking at something that was so unfathomable in terms of distance." And that's kind of the same feeling I get, when I'm looking through my telescopes or taking pictures. You're looking at something that's very old and far away, very far away. And it just, I don't know, it just humbles you, well, it humbled me. And to continue to afterwards, speaking of when she was in high school, afterwards, Beth decided to pursue physics and astronomy at Howard University in Washington, D.C. And her dream was to become an astronaut. So, she took that interest and she went on to Howard University, which is an HBCU. And she took it to the next level. And she's quoted as saying, "Space fascinated me. I was into anything that had to do with space. So I thought that actually being out in space would be the coolest thing possible." So she did her undergrad, like I said, at Howard. And at that time, she did a couple of internships at NASA, picking up research experience and learning more about the science of the stars. And, she had a good supporting cast as well. She had a professor who, once he learned or heard that she wanted to be an astronaut, encouraged her to look at what it takes to become one. You know what I'm saying? So she didn't go on YouTube to try to find out how to be an astronaut and then tell the astronauts how to be astronauts. No, she actually went and did the work. She went to school, she learned about it, and she actually went and put the work in. So she graduated summa cum laude with a degree in astrophysics, and then she went on to grad school at the University of Michigan and became the first African-American female to get an astronomy PhD from the University of Michigan. So that's a little bit of history right there.
Yeah, she's a first.
And after graduating, she returned to NASA for a postdoc position and ended up staying as a full-time employee. So she took her passion as a child and turned it into the way she makes her living. Now, to me, that's heaven on earth. You know what I'm saying? When you can take a childhood passion and make a profit from it later on in life, that, in my opinion, that's a great thing.
Yeah,
and
you winning.
That's called winning. You know what I'm saying? You're going to work every day, but you're not really going to work mentally. You going to do something that you love to do all your life.
Right.
And, for most people, that's happiness. I know it is for me. You know what I'm saying? But to continue as an astrophysicist at NASA, best collected data on the environment of elliptical galaxies. Those are the big round galaxies that we talk about. Elliptical galaxies are thought to be the result of two smaller galaxies merging, and each is believed to contain a supermassive black hole in its center.
Right.
Elliptical galaxies also shine bright in the X-ray region of the electromagnetic spectrum. This means they contain incredibly hot material, 10 million degrees hot. So Beth used NASA's Rosat X-ray satellite and Chandra X-ray observatory to also collect data on these galaxies. So we have plenty of African Americans that are contributing to this worldwide human endeavor we call science in all fields. I'm into astronomy and astrophysics. So those are mostly the people that I keep up with. But when you're dealing with the pseudo killers, you have people that are, pretty proficient in a lot of different areas. So there are many more African American scientists out there in different fields, not just in astronomy or astrophysics. But as a people, I feel like it's our responsibility to uplift those types of people. Your Dr. Motts, your Greg Robinsons, or, all the ones that we've spoken about, of course, your Beth Brown and
shout out
Islers, and it's
Gugega
I feel
Cooper.
like it's Mogiga Cooper. I mean, the list is long. There's more to the African American experience in astrophysics than Neil deGrasse Tyson. And Hakeem Alusier.
But
those are the big dogs.
Hakeem, I'm gonna get you one day, and I think we're gonna make this a norm, just not for Black History, but it was a nice way to kick it off. But I feel like I'm probably gonna try to bring y'all some every time we do the show.
Oh yeah, I think that's something we can do because it's enough of them, Miss Juju.
I mean,
and like I say, I feel like me personally, I feel like it's our responsibility,
right,
to bring those out. I mean, we can't always depend on the white man, as them crazy nuts like
To
to say.
talk about our
You know what I'm
history. It's
saying?
our responsibility to do it
It's
at
it's
home.
our responsibility.
Yeah, it is.
So
So
that's what we're doing, and that's what we're bringing. Because, like I say, this science is a worldwide human endeavor.
yes,
There's no one race of people, which is a social construct, as we know,
right.
that dominates science. No, it's people from
We
all
know
over the
Omar.
world.
We know you
You
love
know?
her, Omar.
Oh yeah. So that's it's important that we learn about these people. Because there's a lot of people around the world contributing to this science.
Mm-hmm.
So,
And they're
like
not
I
all
say,
white.
it's a worldwide human endeavor. I mean,
Mm-hmm.
we just heard about the gentleman in the synagogue, you know, getting some help from NASA.
Miriam Kari.
You know what I'm saying? So
He was getting
there,
help and he was helping NASA.
yeah,
So it was
exactly.
a give and take. It was both ways.
Yeah,
Yeah.
and that's what humans. When you say a human endeavor, that's how it works. You know what I'm saying?
And
But the fact of the matter is, they want to move towards the science and get away from the
mhm.
belief. You know what I'm saying? So wanting to admire what the ancients done, that's cool. I ain't got no problem with that.
Mhm.
But trying to live like the ancients lived in today's time, to me, is
No, thank you.
ludicrous.
I love technology.
That is ludicrous, in my
Mhm.
opinion. You know what I'm saying? Love it. You know what I'm saying? You can love it, but I don't think you can live it in today's times. It ain't gonna work. I'm sorry. I'm not giving up my cell phone. You know what I'm saying? I'm not giving up my telescopes. Not
Yeah.
to go out and try to look at something with my bare. I'm not finna do that.
Yeah. We're not trying to go back to the Stone Ages. I don't know what
No,
you're trying to do. I ain't doing none of that. No herbal medicines. Like, been there, done that. Like,
we
but
we
nah,
have
take
to
me to the
move
hospital.
forward.
Give me them drugs.
Yeah, we got to move forward. The technology is there for us to take advantage of. Most of us walk around with this in our hands, and this is more powerful than what we got our laptops and our home computers.
Mhm.
You know what I'm saying? You can do damn near just about everything you can do on your computer, you can do on your cell phone.
Mhm.
So there's no excuse.
No
No
excuse.
excuse, people.
I wanted to say something real quick about human endeavor. I don't mean to cut your bill, but I just want to add in when we talking about Maram Kari, he speaks French, Wolof, and English, and he needed every one of those languages to communicate with the French scientist that was part of the
Hmm.
endeavor, the Wolof people that he had to cooperate with and whatnot to be on their land because it was
Yeah.
farmers and it was the farmers' land. And to make sure that they could herd their cattle or move them off or any areas that they needed to set up their telescopes. And he had to know English because he's dealing with NASA and the director
Hmm.
of that particular scientific experiment or mission was an American. So I mean, that's phenomenal that he's able to be that flexible to carry on such an endeavor and such a project. Like y'all really have to watch that movie because then he goes to
Hmm.
Istanbul, Turkey, and he
Yeah.
he he wrapping it up with Homeboy. You feel me? So
Yeah. Pretty
that
deep, brother.
pretty deep. So when we say human endeavor, it's definitely a human endeavor, especially when you think about these big projects in science,
Hmm.
particularly astrophysics, and whatnot. So yeah, I know we're at the 2 hour mark. I want you to finish your point. If anybody has any additional questions, maybe we'll take a few, but we don't want to keep y'all forever. I didn't expect to go this long, but y'all was on fire. Y'all came in hot. You know what I'm saying
Oh
with the
yeah.
questions, and I don't mind that. So please don't stop. But I definitely wanted to pause it just to give us time to complete the information we have prepared, so it would be a complete lesson or a complete meal, because we like to give y'all food to eat. You feel me?
Oh
But we
yeah.
had a couple of sides and we had some dessert. So yeah, this was a good dinner. But go ahead, Anthony.
Oh yeah, that was pretty much all I was gonna say, Miss Juju. Just it's scientific literacy is, oh my God, it is so important that we have scientific literacy in this community,
Mm.
because when we understand a lot of the processes that are going on in nature,
Oh,
when you really have an understanding for them, then you can't be fooled or bamboozled or hoodwinked, or as my good brother Bobby Banger like to say, flim flam. You know what I'm saying? So, like,
oh, Omar, that's so sweet.
like I
I
always
missed that.
say, when you scientifically literate,
Uh-oh.
they can't drag you down to their level and beat you up with experience. And that's some real
Yeah, boy.
that's something that can be applied across all the all the way across life. You know what I'm saying? So let's continue to ask questions and continue to seek answers for their questions,
Mm-hmm.
because when I'm dealing with science in my everyday life, I'd much rather deal with questions that can't be answered than answers that can't be questioned.
Right.
Because when you can't question an answer, that's a problem. If that person don't want to be questioned, that is a problem. That means they trying to hide something from you.
Mm-hmm.
And this information we given, I'm not initiated in nothing. I'm not an initiate of nothing. This
Yeah.
is
I didn't get hazed and nothing.
none of that.
Yeah, no,
This
I
was
didn't do none of
just
that.
me. Like most of the people we've talked about, they
Mm-hmm.
had a passion and a drive from childhood or from a young age.
Right.
And that's what did it for me. Do I know everything about the cosmos? Hell no. Not even close. But the little bit I know, I can, pass on to you without any repercussions. You know what I'm saying?
Nice
And,
saying.
I that's just where I'm at. You know what I'm saying? So if y'all stick with us, we're gonna give you the breakdown of it. But if you want to be fooled and told that you are special in any kind of way in this universe, this ain't the place for you.
Mm-hmm.
Because over here we're humble. The universe humbles us over here. You know what I'm saying?
Yeah.
So
I I
that's
just
where
walk
we at.
around. Listen, I just walk around telling them I'm Stardust, baby.
Yeah. And you can say that because you
I
really
know.
understand.
Yeah.
You know what I'm saying? And you can break down why we are stardust.
Why?
But there's nothing I can do on this planet that can change anything going on out in the cosmos, no
Mm-hmm.
matter when my birthday is. You know what I'm saying? So none of that matters. It's all about getting an understanding the best way you can.
Mm-hmm.
And hopefully we can help y'all with this show.
Yeah, baby. Well, I don't see no more questions in the audience. Did we finish all of them from before? Let me
Um,
go back real
I
quick.
think so. I'm not
Finish
sure.
all of them.
They was coming in though, but I love that
Yeah, they was
interaction.
coming in, and I
You
didn't want to
know,
cut it off, but you
I
know,
I love the interaction, and we gonna do a show. It's gonna be number. Y'all get y'all questions together coming up here pretty soon. We're gonna do a show where we can just handle our questions because
that
y'all be
was
bringing
fun.
them.
Or we'll figure it out. I can't
Yeah,
find them now. But
but
if there's nothing else there, we'll see y'all next week. And I think we're gonna have like one more, maybe two more short shows on a stellar evolution. What I want to tell y'all. Oh, Chief Sun Warrior. Yeah, by the way, so Yeah, this is a no, this is a judgment free zone, sir. But I saw your thing about you have plenty of Indian scientists. So if you ever
Yeah,
come to the show, I want you to like bring me 5, or if you can't, my goal is
yeah.
10, like no 10. So bring me 10, 5 to 10 of those scientists that so we can learn about them too. So that's your homework.
Hmm.
That's
And
everybody homework now. See, I need all y'all to bring me some scientists, and it can't be the ones we done named for y'all. And if y'all overlap a little bit, that's fine, but definitely not the ones from tonight. Not no Hakeem, not Dr. Mayat, nobody. So I won't name no more. But yeah, that's everybody homework.
yeah, and I got a couple of book recommendations there for your Chief Sun Warrior. Um, One I like is it's called A Brief History of Black Holes by Dr. Becky Smethurst. That's a pretty good one. And another one
That's
I
not the
find
threat.
pretty
Sorry.
amusing. Another one I find pretty amusing. Well, not amusing, but a good read is The Story of the Universe in 100 Stars by an author named Florian Freistetter. It's FLORIANFREISTETTER. I guess I could have put that in the chat,
Yeah, that's
but
so. I was lost. I don't even remember the first letter. I ain't let me shut up.
yeah, I
Oh,
messed
dear.
that up.
I'm just
I'm gonna put the name in the chat there for you,
I'm
Chief
messy.
Sun Warrior. But
I don't
those
even
are
remember
two
the first
pretty
letter.
good ones, and you can't go wrong with anything by Lawrence Krauss. You can't go
Mm,
wrong. But his latest is called The Edge of Knowledge. That's a
mhm.
really good one. It came out like back in May, so it's a lot of up to date information in there. You got Sean Carroll, The Biggest Ideas in the Universe. That's a pretty good one. I'm working on right now. The Neil anything by Neil deGrasse Tyson.
Right.
The
Oh, and don't forget Moya McTeer,
Oh
um,
yeah, Maria McTeer. Let's see,
Milky
I
Way: The
got that
Story
one
of Our
too.
Galaxy. That's a pretty dope book because
Yeah,
she gives you the science, but she gives it to you in like a story like version, and it's
yeah.
pretty amazing. And just on the Lawrence Krauss part, if I'm not mistaken, so his channel and I think I have it Apperson and not hashtag. If I hope I'm not confused that with the other sign, but that yeah, the ampersand with the A. So you
Hmm.
can't click on that, but his Lawrence Krauss's podcast is called The Origins Podcast, and it's
Yeah.
pretty interesting. So he just doesn't deal with just like astrophysics or space, but he deals with all types of scientific subject matters, but nonetheless it's
Hmm.
fascinating. And I'm sure he has a lot of other space stuff, or just look him up. But the Origins Podcast and his stuff, like, yeah, some of us do follow him. We give you all the resources we have. So I just want to add that. But for like Gugega Cooper and some of the scientists, they're hashtag. So all you have to do is just press on the hashtag. And if there's like a YouTube link for them, it'll take you to, their stuff. And I know Gugega is like kind of everywhere on YouTube and on different platforms and things that are spreading science and scientific knowledge and things like that. So yeah, that's all I had. Yeah, use that description box because y'all gotta watch that movie, learn about them Senegambia stone hedges and Kareem, um, uh, Maram Kyrie. Excuse me. Yeah. Anything else you gotta say to the peoples before we say
Um,
so long goodbye?
that's all I got. You
It's
got any
time
more
for
questions
me
in
to
there?
go.
Um,
I
I'm
do
putting
good
this author's name in the chat so they can
to
look it up.
you
Look it up.
and you and you. So long. Good night. Sound of Music. Yeah.
But this book I'm putting in now, the story of the universe in 100 stars, is pretty good. It talks about different stars that's been located around the universe. With my equipment, I can't see other stars, single stars in other galaxies. But with the equipment that they have, Hubble and James Webb and things, they're able to do that. So that's how they get the information for these books. You know what I'm saying? So, but I'm putting it in the chat real quick.
Chief Warrior, why we need Top Cats on here? Tell me why. Please, I need to know. What he gonna do? You gonna tell me how he related to the star? No, I'm just kidding. But yeah, you go get him over here. Yeah, that's all I gotta say about that. You bring him over there. Everybody bring a friend. Yeah, don't forget to like the show, share the show, subscribe if you already haven't. So, you know, if you don't like nothing else and you like this show, well, you won't miss it. Yeah. So that's the reason to subscribe. But you got anything else to say? If we got nothing else to say, y'all, we are out of here.
Give me one more second. Let me get
All
this.
right, all right. Well, I was about to push
The
that button.
story
Well,
of the universe.
I was about to.
And 100 star.
Oh yeah, yeah. You still doing it? I'm so sorry because it's got like 20 letters in the name.
Yeah, that's pretty long. But yeah, that's it. And all of the books I gave you, I got off of Audible books. So
thank you, Valicia. I really appreciate that. Thank you, Immortal Truth. We appreciate that.
oh yeah, we appreciate all the feedback.
Exactly.
You know?
Glad you enjoyed the show. Yeah, Space Age Africans. In it, motherfucker. I like that shirt you got on, by the way, Anthony.
I appreciate that. Yeah, this
Yeah,
the solar system right here.
Yeah, I see.
You see that?
I was looking at it all night.
At the bottom there, it say never stop looking up.
Yeah, boy.
Always look up. You know what I'm saying? But this my life, Miss Zuzu, Miss Juju. This is what I do. This my life.
Okay.
Scientific literacy all the way, baby.
Scientific literacy all the way. So how do they do that?
But
all right.
Thank y'all for tuning in. Hey, appreciate all the interaction and the questions. Keep them coming. We'll see y'all next Thursday.
All right, next Thursday we out of here. Bye.